Angles in standard position. So we're going to start talking about how to draw angles on a coordinate plane. When we get into some things like radians, this is going to be very helpful. So we're dealing with angles on a coordinate plane. So there's a couple things about where exactly they are. So first of all, the vertex is always at the origin. That doesn't change. The initial side, the first beginning side of your angle, is always on the positive x-axis over here, so that doesn't change either. What moves is called the terminal side. So this is the side where the angle ends, where it's completed. Now, as you're moving to create your triangle in math, we always like to move counterclockwise. So we're considering moving counterclockwise. When you move counterclockwise, that is considered a positive degree. You will come across negative degrees, and that's because it is moving clockwise. So we will come across a negative degree. So on all of these, again, our vertex is going to be at the origin, and our initial side is going to be on the x-axis. So let's go over some basic ones. A 90-degree angle. Well, we have our vertex at the origin, we have our initial side on the x-axis, and 90 degrees is just a nice corner. So there is a 90-degree angle, and it is going from the initial side to the terminal side at 90 degrees. 180 degrees, vertex is at the origin, initial side is on the positive x-axis, and the terminal side would be on the negative side of the x-axis. This is a 100-degree angle. 270 degrees. Again, the origin is our vertex. Our initial side is right here. Now, if I want to go 90, I'm going to think of it as 90 plus 90 is 180, and then 180 plus another 90 gets us 270 degrees. So for this angle, it looks like we would consider it the smaller one. However, remember, we always want to do the counterclockwise angle. So that is our 270 right there. Now let's say we got into something a little more interesting, 215. So we start off with our origin and our initial side. Well, one of the benchmarks I do know is 180. So it's going to be a little bit more than 180. So what I'm going to say is, okay, what is 215 minus 180? Because I want to know, beyond my 180 mark, how many degrees do I have to move? I have to go 35 degrees beyond my 180. So when you're doing this, it is a little bit of an approximation as to what it looks like. So I'm not expecting you to grab a protractor and actually measure. It's an approximation. So I'm going to measure about like right there. So I'm saying this looks to be about 35 degrees. So this was my 180 plus my 35 to get me my 215. Now let's say it was 540 degrees. Well, 360 degrees gets you all the way back to the original. 360 is a circle. So beyond a circle, 540 minus 360 means I went 180 degrees beyond a circle. So here's how we draw this. We start off with our vertex and our initial side, and we get to do this fun little swoop, saying it goes around once, and then I'm going to go 180, so I'm going to end up right there. So while this does look like a 180-degree angle, those little circles show that I actually went one full rotation around and continued for a 180 degrees more. So it's possible to go around more than once. Okay, let's say we went negative. So I told you that we might have a negative angle, again, vertex and our original. So if it's going negative, that means I'm going now clockwise, so it's going to go this direction. So I now went clockwise to get 90 degrees. Negative 110. So I'm going to draw my initial side. Now, I do know 90 goes straight down, so beyond 90, it is 20 degrees further because 110 minus 90 means 20 degrees further. So I need to go about 20 degrees further than 90. So this is my 90 plus another 20 more, and those are in the negative direction because it's going in the clockwise version, which is the negative degrees. How about negative 200? Okay, here's my initial side. Now, one of the benchmarks that I know is 180 goes straight across. So beyond 180 it's going 20 more beyond 180. So I'm going to go 180 plus 20 more. So here's my 180 plus 20 more. And there is my negative 200 degree angle. And negative 340. Well, I know 360 is an entire circle, so if I went negative 360, I'd end up back at its original spot, which means I am just 20 short of an entire circle. So I'm just going to go almost an entire circle to get negative 340 degrees to look something like this. Now, you might be asking yourself, some of these angles look exactly the same. So, or they could be the same as other angles. So what's going on? Well, there's a name. It's called a related angle or a coterminal angle. It is when two or more angles have the same terminal side. And what you're going to notice is the difference between those two angles is either plus or minus 360 degrees. Because remember, 360 degrees is an entire circle. So let's just say that my original angle was 15 degrees. Well, if I went 360 degrees further, 360 plus 15 is 370 degrees. So if I went to my 15 degrees and did an entire other circle, I would land in the exact same spot. Well, 15 degrees and 370 degrees are called coterminal because they're in the same spot. Now let's just say I went the other direction. I started at 15 degrees and I went clockwise backwards 360 degrees. Well, 15 minus 360 is negative 345 degrees. So these three angles are all coterminal. They all end up at the exact same spot. So the way to determine if angles are coterminal is see if they are plus or minus 360 degrees away from each other. So let's try another one. Let's just say I started off with negative 450 degrees. Well, if I went counterclockwise 360 degrees, negative 45 plus 360 would get me at 315 degrees. So those end up at the exact same spot. Now, how if I just continued going clockwise, going backwards, and I subtracted another 360, I went back another full circle, I would be at negative 405 degrees. So these three angles are all coterminal. They end up at the exact same spot. They're related angles. They look exactly the same. So that's how you're going to figure out if angles are related or if they're coterminal, is plus or minus 360 degrees.